every hardware language is used to implement a hardware value. So this was used to get the pixels from the memory and put them in the right coordinates, like in x and y coordinates, so that it's the right dimensions of the block is seen. Offset was also a module that was used to initialize the position of the block. And offset adder was the module that was incrementing the value of the pixels of the block when it was told to move. When a key was pressed, the block moved, so offset adder was responsible to move it to the next position. And VGA, as Raza told, that it's a part of the board, and it connects the monitor and the D2 board. Multiplexers were used to connect the modules of each block together and to give the output to the VGA adapter. Here is a schematic diagram of displaying only one block. So over here we have SSM, a counter, offset, and offset adder. SSM is connected to the counter, and the counter is also connected to the offset. Then from counter, their value is going to offset adder, and the output of offset adder is going to the VGA adapter. So this is to just display one block. To display more than one block, as I told, we use multiplexer. So each block over here is representing the circuit that I just showed you. So all the circuits were connected to the multiplexer, and the output was given to the VGA adapter. The most important part that our design process had was the testing stage. It was the most consuming testing stage. The most consuming stage. So there were two main methods that we adopted to test our design. First of all, by waveform simulation. This was in waveform simulation, we created waveforms of input and output, and then we compared them together to see if the correct output was being given. And the second method that we used a lot was that by actually compiling and downloading the circuit and seeing the display on the VGA, on the monitor or VGA display. So these were the two main criteria that we used to test our circuit. And what we did, we tested each and every part. Like we broke our project into small parts, and then we used to check each part. If it was working, then we used to move on. So there were some problems that we encountered. First of all, the first encounter that we encountered was that all the blocks were not displaying together simultaneously on the screen. Like one used to come, then another one used to come. All of the 9 blocks didn't come together. So another problem that was that when a block was moved to another on top of another block, it would overwrite that block. So the first block would be just erased. And the third problem was that the boundaries were not assigned. If the block was moved throughout the screen, it would go up, or it would come from other sides. So the boundaries were not assigned properly. And the reasons that we thought were for these problems are the idea that we came to finish this problem was that, first of all, the problem for displaying multiple boxes, we thought that there was some problem in the SSM, as it was not controlling, it was not giving proper signal to the multiplexer to display all the pictures. Or there could be a problem in the multiplexer by itself for not selecting all the blocks together. And for overlapping of blocks, what we could have done, we could have made another finite state machine, where we would have defined the positions of all blocks and not allow to move the other blocks when there's a block beside it. For the third problem, to assign boundaries, we actually tried, but it didn't work. We made a comparator, which is a module where the comparator just checks if the block where the block is placed. If it's on the boundary, it wouldn't let it move any more further. So these are the reasons or the solutions that we came up with to solve our problem if we had more time. Now I will hand over to Raza for overall evaluation of our design.
Thank you, Hasnain. And now that Hasnain has actually outlined all the problems that we experienced, it turned out that our design partially successfully worked. Here is a list of the successes of our design. Our design was able to display all the blocks on the screen one by one, not all together, by selecting the switches on the D2 board. Also, we were able to move the blocks around the screen using the keys on the D2 board. Another third success we had in our design was we were actually able to reset the whole 2D Rubik's Cube back to its original position, so the blocks would all be scattered around the screen. The unachieved goals we actually tried were displaying all the blocks on the screen, which was a task we could not accomplish. Another unachieved goal that Hasnain mentioned was we tried to avoid blocks from overlapping each other, but they actually overlap each other, and what happened was the previously placed block erased, the new block erased the previously placed block, so the previous block was actually wiped out of the screen. The third problem we experienced was unassigned boundary. This problem caused the block to go from one side of the screen and reappear from the other, which we tried to set, but we could not achieve this goal. So here are a few improvements that we could have done to improve our design. The first improvement we could have done was increase testing procedures. This would have been done by generating waveforms of the inputs and outputs of your actual circuit, giving inputs to your circuit, and looking what outputs would be actually produced on the waveform. So we could have checked our expected circuit, what it had to output, with the actual waveform that the computer was circuit was actually generated, and then that. So another design improvement which we could have done was set more achievable milestones in the allotted time, which could have been easily achieved. Proper time management skills was an important test to improve our design, doing everything on time. So the major improvement that we could have done was actually start small, test each and every part, make it working, and then go on increasing the size to get the whole product working. Last design improvement was receive assistance whenever possible from all the TAs that were actually allocated in the lab and all their fellow students that were in the lab, and then get assistance from them. And now Hasnain will conclude the presentation.
So at the end, I would just like to tell that what we have learned and what this project has taught us. So this project helped us learn more about hardware design, how to implement them, and how to use them. It also, on the other side, it also taught us how to work in team members with proper cooperation. And as you all know, there were some technical difficulties. So it also taught us how to overcome those technical difficulties, like the server problem. So how to manage these problems. So these are some of the lessons that we have learned. And that's all the way.
We're ready to answer any questions.
When you moved the block, was there animation? Pardon? Did it just go up and a flash and you come up and you make position?
No, it moves.
It doesn't move, right?
Yeah, it doesn't. We have time to keep to move on.
It moves. It can go from one position to another.
Okay. And you have that big SSM that basically controls the way how blocks move, right?
Yeah.
And I guess that would also maintain where is the empty position that you can move the block to.
It was supposed to do that, but it wasn't actually doing it. If that was possible, then it wouldn't overlap, right? But so it was that SSM was supposed to do that. We tried, but it didn't work. There was some problems with it.
It had problems keeping track of where it's going.
Yeah.
And did you also think of implementing a time tracker? Like to keep track of how much...
That was like an addition thing that we would have done. Like you're talking about like the time, how long does the user take to...
Yeah, exactly.
Yeah, that was an addition thing that we could be thought of, like on the D2 board on the head display, we could have shown the time of finishing up. And another thing that we thought we could have shown the number of movements that the user does. But that was an additional thing.
Because for these types of puzzles, having a timer.
Yeah. We had that in our mind, but as you said, we just started off small and then started building, but we didn't have enough time to go through that process.
Okay. And can you also implement a system to detect when the puzzle has solved?
When the puzzle, we didn't reach that point yet. Yeah.